Unit 3, Day 2 notes. Today we're going to talk about angle pairs formed by a transversal. What is a transversal? A transversal is a line that intersects two or more lines. So the pink line in this picture is a transversal because it's intersecting the two black lines. So it intersects at this point and this point down here. Now we need to discuss the difference between interior and exterior. Interior, think of interior design, and if it's interior design, you're designing the inside of your house. So interior is inside, so it is represented by the color green in this photo or illustration. So that means exterior is anything outside, so it's represented by the color yellow. So when we talk about transversals and lines, interior you have to be in between the lines. Exterior you have to be on the outsides of the lines. So let's review vertical and linear angle pair relationships. If you don't remember, let's just first talk about the definition of vertical. Vertical were those bow tie or kissing angles, only sharing a vertex, and form an X when they're together. So we have a couple of pairs of vertical angles. One pair would be angle 1 together with angle 4. Again, because they only share the vertex, and together they form a perfect X. Another pair of vertical angles would be 6 and 7, 2 and 3, and 5 together with 8. So let's write those all out before we forget. So again, they have to share only the vertex and make a perfect X. So angle 1 with angle 4, angle 2 with angle 3, angle 5 with angle 8, and angle 7 with angle 6. Those are vertical pairs. Now let's talk about the linear pair. When we look at a picture, a linear pair should be adjacent and form a line when they're together. Adjacent, meaning they share a wall, and form a line. So we have angle 1 shares a wall with angle 2, and together they form a perfect line. So that would be one linear pair. Then we could also say angle 3 and angle 4 for that same reason, adjacent and form a line. Next would be angle 5 together with angle 6, angle 7, and angle 8. Now, if you look at our picture, those are not the only possibilities. If you turned it sideways, you might be able to see it a little clearer. What I'm saying is, I could say angle 1 can form a linear pair with angle 3. Again, they are adjacent and they form a straight line. So that's another pair, angle 1 with angle 3. So that means angle 2 together with angle 4, angle 5 with angle 7, and angle 6 with angle 8. So as you can see, there's a lot of a lot of linear pairs in this picture. This again was a review of vertical and linear. Now we're about to introduce you to some new vocabulary. The first new word you need to understand is alternate interior. The easiest way or simplest way to remember alternate interior is opposite sides and inside. So again, I'm going to highlight what the interior portion is. I hope I use the right color, but if I don't, that's fine. So everything in I just highlighted in green is considered interior. So in order to be alternate interior, you have to be on opposite sides. So that means 3 and 6 are on opposite sides of that transversal, and they're both inside. They're both in the green portion. So that would be an alternate interior pair. So angle 3 together with angle 6. That also means that angle 4 together with angle 5 is also a linear pair, alternate interior pair. All right. The next new word is consecutive, also known as same side inside. Same side inside. So again, we're still on the inside the green region, in between the two lines, but we have to be on the same side of the transversal. So that means angle 3 together with angle 5 would be considered a consecutive pair. So angle 3 and angle 5, which also means that 4 and 6 would be another consecutive pair. 4 and 6. They're on the same side and they're both inside. Now we're about to talk about alternate exterior. So exterior is what I highlight in yellow. So it's outside the two lines. And to be considered alternate exterior, it's very similar to what I wrote for alternate interior except for outside. So we would say opposite sides of the transversal and outside. So that means that angle 1 is on the left side and it's outside. It's in the yellow region. So that means it would pair up with angle 8 on the opposite side. So it's on the right, but it's still in the exterior portion. So again, angle 1 with angle 8 is a perfect alternate exterior pair. Which also means that angle 2 together with angle 7 would be another pair. So we have two alternate exterior pairs in this picture. Now we're about to talk about corresponding. The simplest way I could describe corresponding is by saying same side, same position. Same side, same position. So I'm going to put all my corresponding answers right here in this little box. So when I say same side, same position, if it's on the one, if the first one is on the left of the transversal, the second one will also be on the left. That's the same side. Same position means if it's above the line, if the first one's above the line, the second one will be also above the line. For example, angle 1 is on the left and above the black line. It's on the left of the red transversal, above the black line. So you're looking for the next angle that is on the left and above the black line, which would be angle 5. So that those two would be corresponding. Okay? So that means angle 3 is to the left and below. So angle 7 is also to the left and below. So those two would be corresponding. Angle 2 is to the right and above. Angle 6 is to the right and above. So that those two will correspond. And then angle 4 with is on the right and below. Angle 8 is on the right and below. So those two will correspond. So again, corresponding angles are same side, same position. So we're just going to practice using the vocabulary we just mentioned with these specific ordered pairs, or angle pairs, sorry. So the first pair we're looking for are angle 1 and angle 6. So here's 1 and there's 6. When I look at angle 1 and angle 6, the only thing they have in common is a vertex. And together, if I were to actually draw the angle or trace over the angle, they form a perfect X. So that means they're vertical. Now we're going to look at angle 6 together with angle 7. Here's angle 6 and here's angle 7. They are both on the same side of the transversal, and they're both in between the two lines. So when they're same side inside, we call it consecutive. And now we're going to look at angle 5 and angle 4 together. Here's angle 5. There's angle 4. Angle 5 is in the exterior region. Angle 4 is also in the exterior region. And they're on opposite sides, so that means they're alternate exterior. Again, we're just classifying these angle pair relationships. Now we're just using alphabetical angle names. So the first one is FEB and ABH. So FEB is here. So it's this angle and ABH. ABH. So essentially it's this angle here. This is the vertex B. So both of those are in the interior region. They're on the same side and in the interior region, so that means they're consecutive. Okay, the next one is GEH. GEH, so it'd be this angle here. Together with CBA. CBA would be this angle right here. So both of those are in the exterior region and they're on opposite sides. So that means they're alternate exterior. And then the last pair, CBD and ABE. CBD would be this angle here. ABE is this angle here. So those only share a vertex and they're kissing angles, forming a perfect X, so that means they're vertical. On this one, they want us to classify each angle pair and name their transversal. So in other words, name the line that is doing the cutting as well. So I'll do a few of these with you and you just finish the rest on your own. So the first angle pair relationship we're going to look at is angle 1 and angle 11. So first of all, the transversal, the line that connects angle 1 with angle 11 is this blue line here. That's line B. So that's the transversal. And so if you look at it, both 1 and 11 are between A and C. So they're in the interior region of A and C. They're on opposite sides of B. So that means they're alternate interior. Okay, let's look at a couple more. The next pair I'll do is 9 and 8. 9 is right here. 8 is down here. So the line that connects 9 to 8 is this purple line, line C. So that's the transversal. So that means 9 and 8 are on the exterior regions of A and B. And they're on opposite sides of C. So that means they're alternate exterior angles. So it's a little confusing, but once you figure out what the transversal is first, it makes it a little easier. So the other lines have to be the lines that determine interior versus exterior. All right, and I'll do numbers 7 and 5. So here's 5. and here's 7. So the line that connects 5 with 7 is line A. So that's the transversal. And 5 and 7 are on different sides of the transversal. So that's an alternate position. Plus, they are in between the other two lines, B and C. So that means they're alternate interior. Again, you should be able to finish the rest on your own. And make sure you take a picture because I'm checking. And this is just another example using pictures to represent angle locations. So real quickly, I'll do one with you and then you finish the rest. So if I'm looking and comparing McDonald's with Taco Bell, McDonald's is up here and Taco Bell is down here. So the transversal on this picture is I-45. I-45 connects McDonald's and Taco Bell together. If you notice, McDonald's and Taco Bell are on opposite sides of I-45. So that means we have alternate going on. And they are in the exterior region because the interior region is everything inside 1960 and green. So everything is in here is considered interior. And since McDonald's and Taco Bell are not in the highlighted portion, they're exterior. So they are alternate exterior angles. Again, finish the rest of this example and take a picture. And this concludes your notes for today.